Chapter 6, Lesson 7, Probability and Odds. So we've got a whole bunch of terms here that we should be aware of, and we're going to come back to these pretty regularly. So the possible results of an experiment are called outcomes. One of those things that if you go ahead and roll a dice, there are 6 possible outcomes. An event is an outcome or a collection of outcomes. So just a bunch of outcomes or a single time that's an event. And then you have the favorable outcomes. When we talk about favorable outcomes, what we're talking about, let's say that you said, I want to roll a dice and I want the number to be greater than 4. If that's the case, then you only have 2 numbers, 5 and 6, that are going to be greater than 4. And you have 6 possibilities. So that means you actually just have 2 ways of getting out of 6, of getting these 2 numbers out of 6 possibilities. We're going to come back to these other terms in a little bit, but let's talk about probability in general right now. So if a jar contains 15 marbles, 16 blue marbles, 5 yellow marbles, and 10 green marbles, you randomly choose 1 marble from the jar. What is the probability that you choose a green marble? So what we have to do is we have to add together all the types of marbles. Those are all the possible outcomes. And then we figure that out based on the favorable outcomes. So right now we got 15, 31, 36, 46. So that's what I did when I added all those together. So there's 46 total possible outcomes. And now I just look at the actual probability that I would select a green marble. So now I'm just looking at this. So it's going to be 10 out of 46, which we could simplify to being 5 out of 23. So that means for every 23 marbles you would select, that you would expect to select 5. So let's move on to the next one. A drawer contains 12 white socks, 4 red socks, 6 green socks, and 10 blue socks. You randomly choose 1 sock from the drawer. Find the probability that you will choose a red sock. Okay, so this is going to be important to remember. But here, 12 plus 4 plus 6 plus 10. That's going to be 16, then 22, then 32. So there's 32 possible socks. And what is the possibility, or what the favorable outcomes? That's going to be 4. So you're going to simplify that. Most of the time you do that, it's going to be 1 out of 8. So let's see here. You surveyed 65 randomly chosen students. Of the students you surveyed, 25 went camping during summer break. Find the experimental probability that the next randomly chosen student went camping during summer break. Okay, so now the amount that went on, this is going to be a little bit harder problem. But if you think about it here, there's 25 people that went on break, and there's 65. 65 total people. Now, here's the problem. This here is what is called the theoretical probability. And if we were to simplify it, we'd come up with 5 over 13. So that's the theoretical probability. When I say theoretical, that means that it doesn't take into account randomness as much. If you've ever gone home and rolled dice, rolled 2 dice, you should always say that you're going to come up with a 7 if you have 2 6-sided dice, because that's most likely, but lots of times you don't. So that's what I'm talking about in terms of theoretical versus what's called experimental probability. Now, experimental probability is when you actually try it. And what you'd have to do with this situation here, you'd have to come up with a system for saying the next randomly chosen student went camping during summer break. So what you could go ahead and do is you could have a total of 13 pieces of paper, and then 5 of them would be red, and 8, so 5 of them would be red, and then 8 of them would be blue. And you put them together in a hat, you choose one, and if you actually came up right, then if you came up with this one here, then you would actually get the probability of it happening being likely, and if it came up with this, then it didn't happen. So the idea is you do this a bunch of times to determine the experimental probability if you want, but the idea is simply that you just go ahead and actually perform an experiment to see whether it's likely or not. So that's what experimental probability is about. You actually try it out. So you are playing darts. Out of 45 attempts, you hit the bullseye 18 times. Find the experimental probability that you will hit the bullseye on your next attempt. So again, one of the simple ways of doing this is setting up a ratio to start with. So it's going to be 6 over 15. It's actually going to be 2 over 5. So that's the experimental probability when I simplify. So that's a pretty darn good shot at going ahead and darts then. So for every 5 darts you throw, you get 2 bullseyes. So that would mean that you just go ahead and, I don't know, there's 2 possibilities, but you would have 5 sheets of paper. Let's say blue, blue, blue would be 3 of them. That would indicate the ones where you didn't hit a bullseye. And then you'd have red, red, where you did hit a bullseye. And then what you do is you put them in a hat, you choose randomly, and you see whether you get it or not. That's going to be the experimental probability, as opposed to the actual real probability. So now in terms of this here, you randomly choose a letter from a bag containing one of each letter of the alphabet. What are the odds in favor of and the odds against choosing a vowel? Okay, so let's think about this. There are 26 letters in the alphabet. And the only ones that are vowels are, and we're not going to count Y, A, E, I, O, and U. So those are the only possible vowels. So there's a total of 5 vowels. Now, when we talk about odds, that's a different thing than probability. They're related. When you add them together, that equals the total amount of outcomes. So when we have it, there's 26 possible letters, but the odds in favor of you hitting a vowel are going to be 5 over 21. So actually, let's flip that around because I just realized that actually it's the other way around because I didn't read it really closely. Where the odds in favor of, well, actually that's the first part of the problem, so I did do it right. This is the odds in favor of getting a vowel is going to be 5 out of 21. The odds against choosing a vowel, you're just going to flip the reverse, so it's going to be 21 over 5. So that's how it works in terms of odds. So if you go back here for a second here, if we were talking about odds and probability here, the total possible outcomes in here are your 45, and your 18 is going to be the amount that you got. So if you figured it out, it would be 18, and then the number that adds together to equal 45. So that's going to be let's see here, 27, I believe. Yeah, 27. So those are the odds in favor of you getting a bullseye, and this would be the odds against you getting a bullseye. Really important to understand. They equal this part here, 45. Both of them do. If you just want odds favor and odds against, you just flip them all. And flip them around differently. Of the last 25 foul shots you attempted, you made 15. Use experimental probability to predict how many foul shots in the next 5 you'll make. So again, 15 over 25 is how many you made. Simplify that, you end up with 3 over 5. So what you could do is, if you wanted to figure out the experimental probability, have three that are like this, make, and then two, let's say that's a miss and that's a miss, put them into a bag that you can't see the result, choose one, and do that a few times, and eventually it'll come up. But you got to put them back, because that's important, because one should not affect the other. You can't just take one out, because this is an important difference in that problem, because it says the next 5 you'll make, and whether or not you made the first foul shot should not make a difference as to whether you made the second one. So that's it.